class today. Let's go ahead and get started with our video today. In this video, let me go ahead and get my pen working here. I guess it would help if I would turn the mimeopad on. Okay, there we go. Alright, in this video, we will be studying word problems that will apply what we learned in this chapter. Remember, no teacher can give you an example of every word problem that covers every little wrinkle and curveball that some word problems throw at you. And to be honest with you, if I could give you an example of every word problem you will encounter in this chapter, I wouldn't do it, because you need to learn to think on your own. You need to learn how to solve problems, and you need practice, okay? Alright, so with that in mind, your heading today is Word Problems Chapter 1. Word Problems from Chapter 1. That's your heading today, so please go ahead and copy that down, and be sure and include today's date, so that your notes are organized, okay? Word Problems Chapter 1, be sure and include today's date. We will be looking at 2 word problems in this video today, just 2. This video will not be long, but you will have to listen and take really good notes. Most of your time will be spent working on word problems in your homework, struggling with them, and getting help from the homework help video. Please do not get discouraged. Some of these word problems are very, very difficult, and you're really going to have to think outside the box. Work hard. Use the help video to help you. Okay, here we go. First problem. Alright, now, if you want to make note, I would make note in your notes that we're on page 73, example 6. That way you don't have to copy down this entire word problem here, okay? So in your notes, I would put page 73, example 6, and then personally, I would turn there in your book, but you don't have to if you don't want to, okay? Alright, here we go. You work in the marketing department of a soft drink company, and you are experimenting with a new can. For iced tea, it is slightly narrower than the old can and taller. For your experimental can, listen to this, the ratio of the height to the radius is 4 to 1. The ratio of the height to the radius is 4 to 1. Write the volume V of the can as a function of the radius r. Write the volume V of the can as a function of the radius r. And then they tell you something else they want you to do right here. But we're going to worry about that after we do the first part of the problem. So the first part of the problem is this. Write the volume V as a function of r. Do you know what that means, students? Let me show you what that means. That means they want you to write volume over here. And over here, you can have numbers, but you're only going to have one unknown, and that's going to be r. And that's called writing the volume as a function of r. Or in other words, you're writing the volume in terms of r. Or in other words, the volume that you're writing depends upon the radius. In other words, you put a radius in, you get out a volume. You put in 6 for the radius, you get out a volume. You put in 10 for the radius, you get out a volume. So your goal is to write an equation that has V all by itself over here. And then it says as a function of the radius r. The only unknown you want over here is r. So V as a function of r, or V based on r. That's what this means. Please take good notes on that and write that down. V as a function of r means V equals, and then you have numbers over here and r. Okay? Alright, so here's what you want to do. The first thing you do, you know you're dealing with volume, correct? Because it says volume. So the first thing I'm going to do is write down the volume of a cylinder, because this is a cylinder, is it not? So let's write the volume of a cylinder. Remember how to do that. If you don't, write this down. The volume of a cylinder is capital B stands for area of base, okay? So you find the area of the base. In this case, it's a circle. You find the area of that flat circle right there. And then you multiply it times the height. Okay? Let's go over that again. To find the volume of a cylinder, capital B means area of base. So we're going to find the area of the base, which is a circle. Find the area of a circle, and then multiply it times the height. So the first thing you do is you start off with the formula that you're familiar with, okay? Which is the volume formula. Now, next, let's go ahead and do some simplifying, okay? So, I just told you your base is a circle, right? So, if my base is a circle, how do you find the area of a circle? Pi r squared. So if I'm going to find the area of the base, I'm really finding the area of a what? Circle. So instead of putting a capital B, I'm going to put pi r squared. Because the base is a circle, and capital B means find the area of the base, and the base is a circle. So I'm really finding the area of a circle. So pi r squared. Okay, now let's simplify it a little more. Then I can just go ahead and multiply all these together. Pi r squared times h is pi r squared h, okay? There it is. Now, would you please listen to me? Do you know what you have right now, students? You have volume as a function of r and h. Right now you have volume as a function of r and h. What about pi, Mr. Earhart? Guys, pi's a number. Pi's not a variable. Pi's 3.14, okay? So pi's fine. It's a number. So right now you have volume in terms of r and h, or volume as a function of r and h. But we want volume as a function of what? R. So we have to get rid of this h, guys. We have to. So somehow we've got to think of another formula over here, or another equation that has h in it and r. Why, Mr. Earhart? Well, here's why. Pretend for a second. Now, this is not a true statement, but pretend this is a true statement. Pretend that was true. What could I pick up and put for h right here? Well, h equals 2r plus 6, correct? So I could pick this up and put it in place of what? H. And then I would have everything in terms of what? R. Because right here for h I would have, my pen is really messing up, guys, sorry. Right here for h I would have 2r plus 6. So all my unknowns over here would be r. So do you see what I'm trying to do? If I can somehow get an equation over here that has h and r in it, then I can work with that. Now, Mr. Harry, how'd you know it was h and r? Because look what I have here, guys. What do I want to get rid of? H. What do I want to replace it with? R. So I need an equation over here with h and r. Guys, I've got it right here, look. The ratio of the height is 4 to 1. The ratio of the height to the radius is 4 to 1. In other words, see this height right here? It's 4 times as big as the radius. I can write an equation about that. The height equals 4 times the radius. That's a true statement, is it not? Whatever the radius is, multiply it by what? 4. And it equals what? H. Now, you probably understand what I just wrote there, but a lot of you are probably saying, Mr. Earhart, I would have never thought to have done that on my own. I understand that, and that's what makes these problems so difficult. And you're going to have a ton of these, a slew of these in your homework, and you have to think outside the box and really think hard, okay? So the height, the ratio of the height to the radius is 4 to 1, so the height equals 4r. Now look, what does h equal? 4r. So what can I put for h? 4r. Definitely, okay? So right here for h, I'm going to put what? 4r. Look at that. Now, I have exactly what I want. I have volume in terms of r. Is this an unknown? No. Is this an unknown? No. This is, and it's r. This is, and it's r. All my unknowns are r. So all I have to do is simplify this now. So simplify it, and you get this. Pi times r squared times 4 times r to the 1 power would be 4 pi r cubed. 4 pi r cubed. There you go. We're done. This is volume in terms of r, or volume as a function of r. Okay, that's it. We did it. Now they want us to write the volume as a function of h. The volume as a function of h. So let's go ahead and take a look at this. Okay, we're going to write the volume v as a function of the height h. Okay, so let's do the whole thing over again. All right. First of all, write down something you know. Write the volume of a cylinder. So here it is. We did this before. So we already talked about this before. The volume of a cylinder is the area of the base times the height. The base is a circle. So you really find the area of a circle. Pi r squared. Pi r squared times h is pi r squared h. So this is good right here. Okay, we're good there. Now here's what we do next. Remember, students, students, just like the last problem, we're trying to write v as a function of h, not r. So look, right now we have volume as a function of r and h, but we really want volume as a function of h, so what do we want to get rid of? The r. So we're going to have to come up with a formula or a equation over here that has h and r in it. H and r. Well guys, we already did that. What's the formula? What's the equation? H equals 4r. Now, the last time, please listen students, you picked up 4r and put it in for what? H. And that got rid of the what? H. This time, we don't want to get rid of the h. We want to get rid of the what? The r. So somehow we're going to have to get r by itself over here. So, divide both sides by 4. And we get this right here. Now, what does r equal? H over 4. So what can you slide in and put for r right here? H over 4. So that's what I'm going to do. So for r right here, I put h over 4. Now notice, there's a power of 2 that I still have right here. Okay? Don't forget that. Alright? So, pi h over 4 squared times h. Now, notice next, I'm going to do some simplifying. I mean, really, to be honest, students, I'm finished. Right now, I have volume in terms of h, or volume as a function of h. There's no other variables over here except h, so really I'm done. But any teacher's going to make you simplify, so I'm going to simplify. So I take the h to the 4th power and I square it. Square h, you get h squared. Square the 4 and you get 16. Now, I went ahead and put pi over 1 because I have a fraction right here. I put h over 1 because I have a fraction here. Now I'm going to multiply them all together, okay? Pi times h squared times h over 1 times 16 times 1. If you do that correctly, you'll get this here. Pi times h squared times h to the 1 is pi h cubed. 1 times 16 times 1 is 16. Okay? We're going to have a bunch of these in your homework. Please work on them. Use the help video to help you, okay? Alright, moving on. Last problem. Now this problem here is just going to be a simple understanding of what the function stands for, making a substitution, and solving. It's really quite simple, okay? A baseball is hit at a point 3 feet above the ground at a velocity of 100 feet per second at an angle of 45 degrees. Now you think you need all this information here, but it's kind of funny, you don't, because they give you the model. So it's nice they told you that, but you don't need it. The path of the baseball is given by this function here. Now guys, look at this function, come on, look at it. F of x equals what? Negative 0.0032x squared plus x plus 3. Dude, students, that's a quadratic equation. Come on, you're pre-cal students. Every quadratic equation is a parabola. It's either going to look like this or like this. And you learned this in algebra 2. You learned this in algebra 1. Whenever your a term or your first term is negative, the parabola opens downward. Whenever it's positive, it opens upward. Okay? Well, it makes sense that this parabola is going to open downward because, look, when's the last time someone hit a baseball and they hit the ball and it went down? Here's the ground. Here's the guy standing here. And he hits the ball. And then when he hits the ball, it goes down underground and comes back up, okay? When you hit a baseball, it's going to have a path like this. Now some might pop it up in the air, others might hit it long, but it's going to have a parabola shaped curve to it. So the first thing you should notice in this problem is we have a quadratic equation, okay, where x and y are measured in feet. Will the baseball clear a 10-foot fence located 300 feet from home plate? Are you kidding? Look at this, guys. Don't be offended by it, but this is so simple. Okay, let's put the batter right here at the origin of the xy coordinate plane, okay? It says the ball takes off 3 feet above the ground, so the batter swings, okay, and he hits the ball right here, and the ball takes off like this. And it hits the ground right over here, okay? Now, how far up is the ball hit? 3 feet. 3 feet. That means this ordered pair right here is 0, 3. Do you not see what to do, guys? If I want to know, let's say I want to know how far the ball is right here, and let's pretend that's over 10 feet. If I want to know how high is right here. And this number right here is 10. Guys, you know what to do. You put 10 in for x, and you get out your y. I mean, look, you know that. I mean, look, all I have to do is go across here, and every time I want to know how high the ball is, just look at how far over you are on the ground and put the number in for x. So think about it. If that's the case, if I want to know if the ball is going to clear a 10-foot fence after, if the fence is 300 feet from home plate, then come over here. Let's pretend. Let's pretend that right here is 300 feet. So, if I want to know how high the ball is, then I'm looking for this ordered pair right here. Over 300 and up how far? Y. So students, all you have to do is put 300 in for x, and that will give you a y value, right? So here we go. Y equals negative 0.0032 parentheses 300 squared plus parentheses 300 plus 3. Now you probably think you're going to get some really weird decimal, but it actually comes out to 15 exactly. So when the ball's traveled 300 feet from home plate, how high in the air is it? 15. So if the fence is 10 feet high and the ball's 15 feet, will the ball clear the fence? Of course it will, yes. So the answer is yes. And if I gave you one of these on a test or a quiz, you would have to explain to me how you got the answer and defend your answer, not just guess and say yes or no. So on this problem here, we're done with the video. That's it, guys. But with this problem here, what I'm trying to teach you is how to understand what a function stands for. Picture it in your mind if you need to, and then understand how to put values in and get values out and interpret those values, okay? Alright, I hope this video has been a help to you. If you have any questions, don't hesitate to call or email.